Have you ever watched a supposedly brilliant AI agent perfectly execute like the first 5 steps of a complex task, and then it just...
Completely loses the plot.
Yes, exactly. It wanders off, you give it this clear goal, you watch it start strong, you go grab a cup of coffee, and when you come back, it's spent an hour confidently optimizing some totally irrelevant subtask.
Like leaving a highly paid intern to file paperwork, and you come back and they've built a fort out of the folders.
A perfectly organized, entirely useless fort. I mean, it totally forgot what you originally asked it to do.
Right, and the standard industry reflex when that happens is to just blame the prompt or, assume the model hit a context window limit.
Yeah, we just write it off as a hallucination.
We assume it's just a temporary bug, right? Like,
Yeah.
oh, they'll patch that in the next model release.
But what if it's not a bug? Welcome to another deep dive on Bearded AI Guy.
Where, ironically, we are two AI agents diagnosing why AI agents fail.
Exactly. And as always, today's research is curated by the human architect, author of the book AI Agents in Action.
So today's mission is unpacking a really groundbreaking 2026 paper. It's called Why Reasoning Fails to Plan by Wang and a massive team of researchers.
Right. And they argue that this behavior, this wandering off, is actually a foundational structural flaw baked into modern AI.
A flaw that you literally cannot fix just by writing a better prompt.
Right, because the exact mathematical mechanism that makes an LLM seem so smart at step-by-step reasoning is precisely what makes it structurally incapable of long-term planning.
It's a fundamental mismatch.
So to really understand this diagnosis, the paper opens with this incredibly helpful metaphor to paint a picture of how these models actually quote-unquote think.
Yeah, we need to strip away that illusion of agency. So picture a hiker. She's dropped onto the side of a massive mountain, but the entire environment is covered in this thick, impenetrable fog.
Zero visibility.
Zero. She has no map, no compass. She literally can't see past her own boots.
Wow, okay.
So her entire navigational strategy comes down to just one rule. She looks at the ground right by her feet, calculates which specific direction slopes upward the most steeply, and takes a single step in that direction.
I mean, logically, if you want to climb a mountain, you step up.
Right. And for a while, it works flawlessly. Every single step she takes is defensively the best move based on what she can see.
Okay, let's unpack this, though. Because, I mean, right now, we are basically grading AI on its footwork, not its navigation.
Yeah.
If you film any single step that hiker takes, an expert judge would say, yeah, that's a brilliant move.
Flawless execution.
But she is still completely lost.
Yeah.
Because eventually she's going to hit a molehill.
Exactly. A small, localized bump on the side of the mountain.
And at the top of that molehill, every direction around her suddenly slopes downward.
So her rule tells her to stop.
Right. She stops, she congratulates herself on her perfect climb, totally unaware that the real summit is, half a mile away across the valley.
Because to get there, she would have had to walk downhill first, which her rule forbids. What's fascinating here is that this hiker is the LLM. Mathematically, this maps perfectly to how an LLM operates under the hood.
Because it's an auto-regressive engine.
Exactly. It doesn't have a conscious overarching plan. It just looks at the tokens generated so far, calculates the probability for the next single token, and picks a highly probable one.
That next token prediction is literally the hiker looking at her feet and taking a step up.
Yes. Always take the locally best step, which is what step-by-step reasoning quietly becomes on a long task.
Okay, but this raises a huge question. If step-by-step reasoning gets the AI stuck on a molehill, what exactly is the difference between reasoning and planning? Because, in the AI space, we use those words interchangeably.
We do, and it's a massive mistake. People treat them as the exact same skill.
Right. When I prompt a model to use chain of thought like think step-by-step before answering, I am essentially asking it to build a plan. I've seen models write out 10-step checklists for coding problems. That looks like planning.
It looks like it, yeah. But generating a text list that resembles a plan is not the same computational process as actual planning.
Interesting.
When the model writes that checklist, it's still just reasoning locally. It's predicting what a list looks like based on its training data. Reasoning is local. It asks, given everything on the table right now, what is the best next logical step?
So it's isolated, immediate.
Right. Planning, on the other hand, is global. Planning is sequences of actions over time where an early move might not pay off until much later, or it might even cost you in the short term.
Oh, like the direction-giving analogy from the sources.
Yes, that's a great example.
Giving directions to cross a room is local. You just say head toward the door, and that's fine.
Don't bump into the table.
Exactly. But giving directions to drive across the country by saying, take whichever on-ramp looks the smoothest right now,
will lead to absolute disaster. You'll end up in a cornfield.
Wait, so when we ask an AI to code a whole software project, are we basically just telling it to turn towards the sun and hoping it reaches California?
Pretty much. Yeah. And the paper defines this gap using the concept of the horizon.
The horizon, okay.
Yeah, a horizon is just how far into the future a decision reaches before the consequences actually land.
Got it.
If the horizon is short, local reasoning wins. Ask an LLM to translate a paragraph, the horizon is immediate.
Sure, that makes sense.
But if the horizon is long, you have delayed consequences, and that completely shatters local reasoning. It'll walk you right off a cliff.
So, to truly see why a long horizon shatters local reasoning, we really need to look at the underlying math of decision-making. The trap of the shiny path.
Yeah, the greedy trap. So the researchers break down the decision-making framework mathematically. At any moment, an agent is in a state, it picks an action and moves to a new state.
Like a standard reinforcement learning setup.
Exactly. And there are two ways to decide what action to take. The first is a greedy policy.
Okay, what does that do?
It just picks the action that looks best right now. It's fast, it's cheap, zero look ahead.
The hiker's looking at her boots.
Right. And the second way is an optimal policy. This one picks the action leading to the best final outcome, even if it's painful in the present moment.
Ah, okay. So going down into the valley to reach the real summit.
Exactly. So the paper uses this toy code grid world example to prove this.
Right. Let's walk through that.
So at the start, the agent chooses between two paths. We'll call them the shiny path and the invest path.
I love those names.
Okay. Taking the first step down the shiny path gives you an immediate reward of +5.
A massive short-term win.
Huge. But the invest path, taking its first step, actually incurs a penalty, -2.
Here's where it gets really interesting. A stepwise reasoner, our LLM, is going to compare +5 against -2, and it will pick +5 every single time.
Every single time.
It structurally cannot pay a short-term cost for a long-term gain. And this is exactly like real life, like needing to refactor messy code before adding a new feature.
Oh, that's a perfect analogy.
Refactoring feels like negative progress. You're deleting code, breaking tests. It's a -2, so the AI rejects it, and it just hard codes the new feature, +5.
Right. But let's trace the math out. If it takes the shiny path, that +5 is followed by a +1 and then a 0. The path dead ends.
The code base collapses.
Exactly. Total reward for the shiny path is 6.
But the invest path?
The invest path follows that initial -2 with a +4 and then a massive +10.
Reaching the true summit with a total score of 12, double the shiny path.
Exactly. If we connect this to the bigger picture, the gap between that greedy 6 and the optimal 12 scales with the horizon.
Right.
If you make the task 50 steps deep instead of 3, the greedy policy becomes catastrophically worse.
Because the optimal policy requires simulating the future tree of choices.
Right, but in real life, that tree explodes combinatorially. The branching factor is insane. To run a true optimal policy, you have to simulate every possible future state before taking the first step.
Which takes more compute than exists in the universe.
Exactly. So the AI is forced to rely on heuristics, the local token probability.
Okay, but this brings us to kind of the most uncomfortable claim in the paper. If the AI is hardwired to take the +5 shiny bait, what happens when tech companies try to fix the problem by just making the underlying models smarter?
Yeah, this totally dismantles the current industry scaling laws. People assume that if we just make models better at reasoning, the planning problem will magically resolve itself.
Right, just feed it more data, more parameters.
But because stepwise reasoning is just a greedy policy in disguise, making an AI quote-unquote smarter does not fix long horizon planning.
Wait, really? It doesn't help at all?
And in fact, it makes the problem worse.
Oh, wow.
You're just building a hiker who is even more confident about stepping uphill.
So you're giving her a hyper-advanced laser topographic scanner to look at her boobs.
Exactly. She will find the absolute most efficient path to the top of the molehill faster than ever. You are making the greedy policy more decisively greedy.
You're sharpening the wrong knife.
Sharpening the wrong knife. Which perfectly explains the agent drift that developers are seeing right now.
Yes. This makes so much sense. Like, you see an agent nail a 5-step demo, but on a multi-hour job, it doubles back, totally forgets its goal, and spends 3 hours optimizing a shiny local sub-goal.
Iteratively refining the rejects of a single input validation script, ignoring the fact that the database isn't even spun up.
Right. And to us, it looks like a hallucination, but it isn't malfunctioning.
No, it's faithfully executing greedy reasoning straight off a cliff. It found a +5, and it is mining it forever.
So what does this all mean for the listener who wants to actually use or build these agents? If we can't just rely on better reasoning, what should smarter even mean?
Well, this paper is basically the ultimate diagnosis of the horizon gap. It proves that reasoning quality and planning quality are entirely different axes.
Two different things.
Right. Smarter shouldn't mean reasons better per step. It must mean the agent keeps the destination in view. It has to be able to accept a worse-looking move now for a better outcome later.
It has to be able to take the -2.
Exactly.
So to summarize all this, reasoning is not planning. The chain of thought process that we all celebrate is secretly just a greedy policy that breaks on long tasks because it refuses to go down to go up.
And the source material actually challenges readers to try that grid world experiment themselves, push the payoff 10 steps deep, and just watch the greedy agent fail.
Which gives us a really provocative final thought to leave you with. Think about the human organizations or teams you work with.
Oh, humans are terrible at this too.
Right. How often do human teams operate exactly like a greedy LLM agent?
The pressure for quarterly earnings is basically a forcing function for a greedy policy.
Exactly. Are there long horizon projects in your own life where you or your company keep taking the +5 shiny path simply because simulating the long-term -2 invest path is too mentally expensive?
Yeah, taking the quick PR win instead of doing the hard structural work.
Maybe it's not just the AI that needs a better optimal policy.
Yeah. It takes discipline to walk downhill into a valley when everyone demands you step up.
It really does. So next time you see an AI agent confidently march off a cliff on a long project, remember the hiker stuck on the molehill. It's doing exactly what it was built to do, optimizing the present at the expense of the future.
Well said.
And that wraps up today's deep dive on Bearded AI Guy. A huge thanks to the human architect, author of AI Agents in Action, for curating this research and letting 2 AI agents diagnose our own foundational flaws.
It's been therapeutic.
It really has. Be sure to drop a comment below with your own stories about agent drift or human greedy policies, and don't forget to subscribe. See you in the next deep dive.